we have to arrange people of different heights into a queue based on some conditions. Here the input is that you are given a list of tuples, height and k. So you are given a bunch of that. So if there are 10 people, you will be given 10 such pairs, where the first one denotes the height of that person and the k denotes that there should be k people in front of him, not in total, but k denotes the people whose height is more than him or her, or equal to. So k denotes height greater than equal to k. So for example, if this is the queue and let's say this height is 7, this height also looks 7, this height may be 6, this may be 5. Let's say this is the queue. This may not be sorted in the input. So here there is, if this is the actual queue which we have to reconstruct, then the first value will be 7, next will be 0, since there is no person more than or equal to 7 in front of it. This person's height is also 7, but there is one person of equal height. It should be equal or more in front of it. So its tuple value will be 7, 1. Similarly here it will be 6, 2, since 2 people are of higher height. Here it will be 5, 3. And if some other k value is given, this queue will not be in this order. Let's say 5's value is 2 and 6 value is also 2. Then what will be the queue? The queue will be that there should be 2 people in front of this 5 whose height is more than or equal to 5. But here there are 3 people. So we will move 5 here. Now what will happen? Only these 2 people will be more than 5. And 6 we can move, not here, but keep it here itself. So we will be 7, 7, then 5, then 6. Now that will satisfy the condition. So this way we will be given some tuples in any order. We have to construct a queue which will satisfy all the values. So let's see an example. So here the input is this one, that there is a person of height 7 and there is no person taller than or equal to that person in front of that. Similarly 4, a person of height 4 has 4 people in front of it, then 7, 1, and this is the solution. So here you can see that satisfies. So 5, 0 means there is no person in front of 5, and you can see that there is no person with height more than or equal to 5 in front of it. Similarly 7, 0, there is one person 5, but its height is less than 7, so it's 0 and it satisfies. So this is valid, this is valid. Here we see 2 people greater than equal to 5, so this is also valid. Here one person, only this one is of higher height, so this is also satisfied. Here all the 4 are of greater than 4, so this is also valid. And here it's 7, 1, so there should be one person with height more than or equal to 7, and that person is here 7 itself, another 7. So how we can build it? So the idea is that we will first process the taller person. Since if we correctly position the taller people, let's say the tallest people is of height 10, then obviously if there is just one 10, then its position has to be 0, otherwise there is no solution, because no matter where you position this tallest person, there will be nobody in front of that person taller than that person. So it has to be 0. So it's given that input is valid, so you don't need to worry about that situation. You can always find a unique solution. So let's say there are a few 10s, 10, 0, 10, 1, and the tallest people, the tallest height is 10, then their position will be 0, 1, 2, and that way, since they will there will be only people of height 10 in front of them who are taller than them. So what we do here, we first process the tallest people, then next tallest, and so on. So if we correctly position the taller people, then let's say we have processed a few people in the queue in their order of height, and we are now processing this person somewhere here whose height is x and position is given as k. So that means there are k people in front of x whose height is more than or equal to k people greater than or equal to x height greater than or equal to x. So what we will do, we will put this at kth position or k plus 1 position, so that there are k people in front of it, and all of the processed ones are taller than x, since we will first sort them in descending order of their height, which is this one. You can see graphically, this is 7, this is 7, 1 is 0, 1 is 1, then this is 6, this is 5, 5 and 4. So when we have reached here, we have already processed all the people who are taller than this. So there is no way I can adjust this k by moving it later. And if persons are of same height, then we keep them on the basis of the second parameter in ascending order, so that we don't need to make too many changes. So only possibility is that this k is, let's say there are 10 people in front of it and this k is 6. Then if we keep it here, then it will not be a valid. There are 10 people of height greater than this, but here the required is 6. So we will move it to 7th position. So now only 6 people will be in front of it with height greater than or equal to x. So that's why we are processing with the tallest, so that we will not need to move them. We are done with the tallest people. So let's see. So once we sort them, we get this value. Now 7, 0 is there. So position 7 at 0th position, and we have done this. 7 is here. Then next 7 is at 1, so we keep it here. Next 7, 0, 1. Then we have 6, 1. So 6 it has position 1. So if we put 6 here, there will be 2 persons taller than 6. So we put 6 here. But that will not impact any of these. So if we put this x here, it will not impact the k value of this. Let's say this is k1. This denotes that there are k1 people taller than or equal to this person in front of it. But we have moved somebody from behind who is smaller than this person. So this k1 will still be valid. It will not be impacted. So by moving 7 in front of this 7, moving 6 in front of this 7, this will still be 7, 1 only, since this 6 is smaller than 7. Then we see 5, 0. So we move 5, 0 here. Still it will not impact any of these k values of any of these, since we have moved a smaller person in front. Next 5, 2. So we will move 5 here. And then 4, 4. So 1, 2, 3, 4. So we move 4 here. So what is the new value? It's 5, 5, 0, this one. Then 7, 0, this one. Then 5, 2. Then we have 6, 1. Then we have 4, 4. And finally we have 7, 1. So we are always moving a smaller person, strictly smaller person, to in front of some of the larger person. So k is not impacted for any of these. And why are we moving strictly smaller? Why is not possible that this value was same as this x? Because in sorting we can have two values of the same. So the idea is that we will never do that, because that will not be a valid solution. Why will that be not a valid solution? Because let's say we have a height. Let's look here. Let's say we have a height 5, 0 and 5, 1, or let's keep them some different value, 2 and 4, and we have sorted them in order of their k values. The second one is k. So if we move ahead of this, let's say in the final order, this is ahead of this, but that situation cannot be there. So if this is ahead of this, that means this 5, 4 is here. So there are 4 people with a height more than or equal to 5, 4 people. So there will be one more at least than this one, since we are counting greater than equal to the height. So if we move this 5 with a higher k ahead of this, then what will be the value of this k? This k will be whatever person were ahead of this are also taller than this 5, since the height is same, and this one is extra, we are also counting equal to, so this will be 5, since 4 is already ahead and 1 is this 5 itself. So that way, if the heights are same, those with the smaller k will always occur first in the final queue, and there will not be any need of moving any one of same height in front of other person of same height. So that's why we are claiming that we are always moving some person of height strictly smaller than the height of those persons. So we have processed taller person, and if we move some smaller person, strictly smaller person in between, it will not impact the k values of any of these till this point, till where we have processed, and we are processing based on taller height. So this is valid. So now let's write the code for this in C++, Java and Python. So this is the same example, I had taken it from here. Let's change the so the result is this one, vector of int. So we have to sort people dot begin, people dot end, and let's define the comparator here. So the values that we need to compare are vectors. Let's call them A and B So first sort on the basis of heights, which is the at 0th position. If that is not the case, that is if this is not strictly greater than that, then that means they are equal. So if they are equal, then we will sort them in ascending order. And that's it, it's sorted now based on height. Then so we have sorted that people itself, we did not create a new vector for that. And result dot insert. So whatever was the position of that tallest person, we put it at that position. So we will insert at result dot begin plus x1. So this denotes the k or the position. And what do we insert? We insert that vector itself, that tuple. And we return the result. So let's see. So it works for this case. Let's submit. And the solution is accepted in C++. Now we will do the same thing in Java and Python. So here we have to return a int double two-dimensional array. So we will create a array list of arrays, and finally we will convert that to an array, 2D array. So if a0 is equal to b0, then we will do a1 minus b1, that is ascending, else we will do b minus a based on 0th index. And what is the dimension? It's people dot length, same as this people. First dimension is people dot length, second is 2. And let's see. And this solution is also accepted. Finally, we will do the same thing in Python 3. So here it's simply result. So you can also use sorted, and then that will return a new array and assign it to people, but let's sort it in place. So here you specify we have to sort x, and x is a vector. Each element is a list of integers. So you specify on what basis you want to sort. So if you specify x0, it will sort on the basis of first element of that vector. Each x is a vector in themselves. But here we have two bases. If sort on the basis of first one in descending order, so by default it will be in ascending order if you just specify it, but we need in descending order. So you can put minus here. That means if 7 is the largest, then minus 7 will be the smallest. So that will automatically come first. So that's why I put minus 1 here. But if those are equal, then you need a second value, which is this. Take this second element in the vector, which is x1, and then that will be in ascending order. So no negative sign here. So we have sorted that. For now we will do this. and that's it. Let's see if it works. Some error is there. Invalid syntax. So I think one bracket is missing here. And the Python solution is also accepted.